Good afternoon. Thank you for the opportunity to present some of the results of our research project on the River Hamble today. Apologies that we couldn't be here in person. If you do have any questions afterwards, Karen kindly agreed to collate these and we will respond to them in due course once back in the country. My name is Ilse Stale and I'm from Aquas Limited. We're a small aquatic research and consultancy SME. We've collaborated on the project with Sand Geophysics, a small marine geophysical survey company, and both of us are based in Netley in Southampton. The other members of the team are Dr. Simon Bray, also from Aquas Limited, and from Sand Geophysics, Tom Chamberlain and Ben Owen. I'll start off with giving a brief overview of the history and reasons behind the project, then explain the methodology, show a few of the results, and discuss some of the limitations and our expectations of how to improve this type of work in future on similar types of habitats. I hope I don't need to highlight the importance of Saltmarsh to this audience and its role in coastal protection, flood protection, ecosystem support, carbon sequestration, and pollution amelioration. As we all know, the habitat is detrimentally impacted by coastal squeeze and sea level rise, excess nutrients, and subsequent algal smothering, as you can see in the photos included in the slide. We have been involved in studying saltmarsh decline within the Solent since the late 2000s, and in 2016 undertook a feasibility study on the viability within the River Hamble for the use of soft sediment to improve habitat retention. The project area is private property where the landowner has been proactive in investigating opportunities to reduce saltmarsh erosion and to consider habitat restoration trials. Funds for the research project were awarded by the Solent Natural Environment Group in 2020 and matched by the landowner. Due to COVID-19 restrictions, the project started in March 21. However, during 2020, all the necessary permissions were obtained for the work from the various regulatory organizations. We installed the structures over a weekend in March 21, as you can see, hard at work, with the assistance of Rainer Piper of Fathom Ecology. Here the study area at Land's End on the River Hamble is highlighted within the red circle. The zonation is mudflat leading to Pioneer Marsh and then secondary marsh. The intention with the work was to try and assist the retention and accumulation of sediment within the eroded area, potentially providing a foothold for pioneer saltmarsh plants to establish that will retain further sediment and encourage growth of lower marsh species. The design tried to take into account the ebb and flow of the tide, being mindful of not creating areas where further erosion will be encouraged. 8 choir rolls were installed, held in place with chestnut poles and hemp rope. We also installed 4 coffee sacks made of hemp and filled with brushwood along the top edges. Here you can see the area after the installation of the structures. Traditional monitoring methods, for example using quadrats, ranging poles, etc., is time-consuming and harmful to the habitat. We opted for using unmanned aerial vehicle technology instead. Permission for 6 drone flights was obtained to monitor change over the time period March 2021 to December 2022. The drone was flown at a height of 40 meters above ground to ensure positional accuracy to allow for comparison between the different flights. Ground control points were used where exact coordinates were logged at 6 locations across the site using RTK or real-time kinematic survey technology. This provided a positional accuracy of less than 1 centimeter. The same flight plan was used for each of the surveys undertaken. The images were processed and stitched together to generate orthomosaics. Each of the images had between 70 to 80% overlap with other images, and the crisscross flight pattern allowed for gathering information from different angles. In addition to the orthomosaics, 3D models of real-world scenes were generated. These in turn were then used to measure change, both vertically and horizontally. The calculated absolute accuracy of the elevation models were less than 1.5 centimeters horizontally and less than 2 centimeters vertically. Here are 4 of the orthomosaics generated for March, June, September and December 2021. The March flight was before the structures were installed. The orthophotos allow for a comparison of vegetation extent between surveys. The images show the progression of algae accumulation through the seasons and the change in salt marsh growth. It also shows the difficulty of using RGB camera data to try and perform direct comparison of datasets. Lighting and color balance will have a big effect. The surveys could only be undertaken during low tide conditions, which impacted light, as you can see from the difference in the time of day the various flights were flown. Change comparison images were generated between the different time periods. As an example, this is the elevation change image between December 2021 and December 2022, therefore spanning a full year and seasonally comparable. The purple colors show an increase in elevation, whilst the green shows a decrease. The scale, which I do appreciate you most likely can't read, ranges from minus 0.52 to plus 0.43 meters. This sounds extreme, but some of the high elevation differences are within the areas where positional accuracy is less, notably to the southwest of the image. Reflectance of water that hasn't drained away at the time of the flight can also produce erroneous results on the mudflat. The area where the structures were installed has a maximum value of plus 0.18 meters, notably in the area to the north of the site, circled in blue, and also just behind the structure to the west. The area circled red is of concern. The brushwood-filled coffee sacks had no impact, and the erosion in this area is continuing. This video demonstrates how the elevation increases towards the saltmarsh vegetation through the cross-section, highlighting the 3 choir rolls. The image at the top shows the location of the cross-section and the location of the structures. The elevation is for the December 2021 data. The chart depicts the same cross-section for both the December datasets. The green line is for 2022, whilst the blue line is for 2021. The elevated height up to about 10 meters along the x-axis is most likely due to the reflection from water. Around the choir roll structure, the water drained away, and these show a true reflection of elevation range. A number of lessons have been learned during the course of the project, which will assist us in improving our workflows. It is a challenging environment to work in, both physically and using remote technology. For example, since the ground control points were temporary and in most cases will always be, meaning that they were not always placed at exactly the same locations during repeat surveys, there is a reduction in location accuracy. Having permanent fixed ground control points would be preferable, but isn't always possible. Drones with inbuilt RTK sensors will assist in improving accuracy. RGB data also makes it difficult to visually compare between repeat surveys due to different light conditions, although the recording of area change can still be achieved. Some improvements that we would incorporate are to use multispectral and/or LiDAR sensors to assist in improved elevation calculations and vegetation health. In terms of the success of the structures, Additional structures potentially would have improved the situation, but the high nutrient loading in the River Hamble means that algal smothering is a big problem, and any vegetation that started to grow in the summer very quickly were negatively impacted by algae. Some form of structure that could reduce the algae influx, as well as the velocity of the water, would potentially work. We are currently looking into adding something to the site that could mitigate some of these negative impacts. That's it. Thank you for your attention, and again, apologies that we were not here in person. We are finalising the report for the project where more detail is presented. This will be made available in due course.